All right, who had a good week? Did you have a good week? Yes? I had a not so good week. Did you hear what happened to me?
Yeah, you were in the ER.
Yeah, I had surgery. Yeah.
Are you
so
okay?
I'm okay, but it was kind of crazy because so what happened was last Tuesday in class, like around lunchtime when we were doing lab, like I had a tummy ache, but I thought it was just tummy ache. You know, whatever. You get tummy aches. People get tummy aches. And it didn't go away. It stayed all day, and it started in the front, but by the afternoon, it had wrapped all the way around. It was like in my back, and it was really weird, and it was a weird kind of stomach ache. Like it didn't feel like a normal stomach ache, and I kept thinking, well, if I walk, it'll help. If I take a warm shower, it'll help. I'm like,
I love warm showers.
It was appendicitis. So what I ended up doing was I went to bed that night, and it was still hurting. And as I was laying there, I noticed that it didn't hurt in the middle anymore. It hurt way over here on my right. And I thought, oh no, because that's usually either a gallbladder or appendix, right? So I came downstairs at like 1:30 in the morning because I remembered that before I went to bed, I was more comfortable. And I thought in my delusion that sitting up would make it better because when I was sitting up, it didn't hurt so bad. But really, it was just the passage of time that had made it worse, not the laying down. So Jason woke up to go to the bathroom at like 3 in the morning, and he noticed I was gone, and he yelled down. He's like, "Are you down there?" And I said, "Yeah." I was on the couch, like, oh, and he said, "You okay?" And I said, "I don't think so." So he came and got me. No, have you had yours out? It's terrible, but the appendicitis is bad, but the surgery was crazy easy.
I've had 3 surgeries.
Crazy.
They knocked the anesthesiologist, like, that's my first time going under. And like, so all your, because she's like, so the basic question is, am I going to wake up during surgery? She's like, no.
Hey, Julia.
So
I broke my collarbone.
she just says, count to 3. 1, 2.
Yep. Well, it was weird.
When you wake up, you can't move your jaw.
They determined it was my appendix, and they gave me, it was like probably 2.5 hours after that where I had to wait on the surgeon to come in, and they kept pumping me full of pain meds and stuff. But this is what's crazy. From the time I got to the ER till the time that I got home was 14 hours. And it's life-saving abdominal surgery in 14 hours, and I'm in and out. That is insane. Because, like, we were coming back in the neighborhood, and my husband remarked, he's like, 150 years ago, this would have been a death sentence. And he's right. Because, so your appendix is the bottom of where your small intestine joins to your large intestine. It just kind of hangs off your large intestine at the bottom. And it's what they call a vestigial organ, which means that it doesn't, we don't know what it does. It doesn't really have a purpose. There's thoughts that it's sort of like cows have 2 stomachs. Some animals have like a ruminant stomach where they kind of let stuff almost ferment, but not ferment for a while. So there's thoughts that maybe there's some evolutionary link like that, or maybe it produces some hormones or neurotransmitters or something that we don't understand yet. But there's all these theories about what it does, but basically all it does now is get infected in some people. And if it gets infected and you don't take it out, it can explode, and it fills your whole body with like basically poison, and you can die. So it's crazy that in 14 hours, I came home and everything was like normal. So I have like 3 little holes because they do it laparoscopically now. They used to just cut you open, but now they do 3 little holes. They do 1 in your belly button that has the camera and the light, and then they have 2 over here. Yeah, and they come in with these. Well, it doesn't go anywhere. It's just a scar from your umbilical cord. But they open that up, and they poke this little thing in, and they blow your belly up so you can see in there. It becomes like a circus tent.
I'm officially grossed out.
Are you? Good. I did my job then. I love grossing people out.
I'm
All right.
Can I tell this? Watch out for the appointment.
So let me switch over to my screen here.
Less than 14 hours, though, right? Because you just had to stay in the recovering room.
No, I mean, like that was the thing. It was only
like 11. Mine was 12 hours. We got there.
How fast was the surgery itself? Just right
it's like 45 minutes. It's not long at all.
You should know this.
Now I've never had my appendix taken out.
So let's
never even had surgery.
No, you
I don't want to
only
have
a
surgery.
scope.
Well, you don't want surgery.
No,
I've
you
had
don't.
3, and it hurts. I've had stitches.
I've had to get my tonsils out. I've had to get surgery on my ears.
I was acting like a dog once, and I broke my fell off, and I broke my collarbone.
Oh my goodness.
I was acting like my grandma's
Ethan
dog.
broke his
on
arm.
top of the couch, and I fell.
I have a friend who, when we were really little, he pretended to be Superman.
What?
And he
jumped off the couch.
He jumped.
off the
I don't know what that's about. Hang on, don't ring yet, guys.
We're not. It's just.
Is it doing it on its own?
Shaking.
Yeah, that one's a weird one. Anyway, he didn't jump off the couch. He jumped off a stack of chairs, and he landed badly and damaged his eye. So
when I went to the lake with the A-lifts, I didn't want to jump off, so my dad threw me in, and because I wanted to, went head first.
Oh, all right. I'm going to hand back your homework from last week. Keep your homework that's in there right now, because if there's anything that y'all didn't understand, I want to make sure we go over it before you hand it in. All right. So, whoops. That's you.
Does everybody at one point have to get their appendix?
No. Here you go.
My mom and dad.
Well,
The new one.
Yeah. Yes. Jackson. And I guessed you correctly, Andrew. All right. And then, so Savannah wins our Rico contest. All right. This was our rock star. I particularly loved it. Drew, you get an honorable mention. Will you show yours real quick? So Drew actually did his as a Back to the Future reference, which was pretty awesome. That's a total Marty McFly right there.
Yeah.
And I was loving that. But I love the shading on this one, Savannah. And okay, so apparently over the summer, some people were up in the schoolroom and they ate all of my gummy bears. So I've ordered more, but until then we get Cruddy Mints because that's the best I can do. Awesome.
Wait,
so
you ate all the gummy bears?
My children.
From
Did you do that?
No, it was cold.
It was cool.
Honestly, I would eat all the gummy bears.
All right.
The guy who's not here.
So let's go ahead and go forward with our lesson for today, so we can get that done. So go ahead and open up to your lesson 2, forming a hypothesis, and let's look at our notes and make sure we have all the blanks filled in. It looks like everybody got logged in on the computer, and it looks like everybody got their tests done. Excellent. So turn to lesson 2. There you go. And you're going to want to put your homework back in. Like you're going to want to clip it back in where it came out. So that's after lesson 1. If you want to take a second and do that first, that's probably a smart thing to do.
Oh, in lesson 2, my dad put a note.
Clip, yeah, go ahead and clip that right there. Yeah, I know. That's what he just talked to me about at the door. So yeah, just clip that in there so you don't lose it, right? I'm going to keep your homework. If you can't read the comments I put on your homework, let me know. I realized about halfway through that I was writing in cursive, and I don't know if all of you can read cursive.
No, we cannot.
Oh, maybe you'll have to learn. No, I'll do my best to print. I'm just not used to it. Okay, so we talked about hypotheses. All right, so can somebody tell me, looking at the first paragraph that says, what's a hypothesis? Can anybody put that in their own words? What's a hypothesis?
Wait, where is it?
So we're looking for lesson 2.
Here we are.
Lesson 2.
Is it this?
Yup, turn your page to the first page of your notes right there.
Oh,
Very good.
I remember this.
Very good. Perfect, 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 perfect. You got it? One more. The lesson 2. Is that 2? Oh, I think that was it. You had it, didn't you? Go back.
I think this is 1.
Is that lesson 1? Oh, okay, fine, 2. You got 2? You got it, Sky? Good. All right, excellent. Savannah got it. One more. Keep going.
Yeah, I put it somewhere.
Oh, okay, that's fine. Keep flipping. You'll see it. Make sure we got it. Right around there, I see notes. There we go. There we go. Score. All right, awesome. All right, so can anybody put a hypothesis in their own words? You want to try? Go for it, Drew.
It's like an educated guess.
Yeah, very
Like
good.
the Weather Channel.
Very good. Would anybody volunteer to read that first paragraph? Go ahead.
A hypothesis is proposed explanation for an observation.
Mhm.
It is a prediction
Right.
or explanation that is tested by an experiment.
Excellent. Keep going. You got it.
Okay. It is a tentative
Very good.
answer to a scientific question. In science, a hypothesis is part of the scientific method.
Very, very good. Excellent. That was really good. Thank you, Eleanor. Very, very good. I love it when people volunteer to read out loud. You never have to. You never have to, but it's very good practice. And everybody in this group is totally cool, right? Everybody in this group knows that some of us have serious reading challenges. So this is the place to practice and be comfortable with it, right? Good. Because we're a nice, cuddly group. Nobody's going to go, if you can't read some word correctly, right? No, we aren't those people. Excellent. So had anybody heard hypothesis before? Had anybody heard? I don't know. You've heard of it before? You'd heard the word before? Excellent. Have you heard it before?
Yeah.
Okay, good. So for some of you, it was a new word, and for some of you, it wasn't. All right, so let's look at that second paragraph, and I'm going to pause when I get to the first blank, and I want you guys to tell me the answer by ringing the bell. And whoever I hear first, you have to share the bells. So, okay. There you go. Observations and experiments may disprove a hypothesis, but they can never entirely
support.
Wait. Yeah, prove or support. Excellent. Now, in the video, I explained to y'all that a lot of the times the word prove is used. Like I think the book, the older kids' book used prove. A lot of internet videos are going to use prove. But really, we like the word, you said it? Support is better, right? Support or not support. Or what's the other?
How about we just press the buzzer and then use it? Instead of us screaming it out.
We can do that.
And we're like,
Let's do it again for the next one. And let's, instead of buzzing, everybody say it at the same time. So the next sentence, most scientific hypotheses, that's plural, right? Hypotheses are proposed in an if-then format because it's easy to design an experiment to see whether a cause or effect relationship exists between the independent variable and the dependent or responding variable. Okay, the hypothesis is written as a what? Prediction, good. Okay, good. Of the outcome of the experiment. All right, this independent, manipulated, dependent, responding business. All right. Now, I think I talked about this some in the video lesson, but generally speaking, most of the time, in my experience, as somebody who did 4 years towards a bachelor's degree in a science, dependent and independent and control are the words you hear. For whatever reason, that's okay. The older kids textbook, which is this textbook, which is interesting because if you notice, this textbook,
very small.
Yours is a little smaller, but here's what's funny. They're produced. I mean, they're published by who? Let's see, Pearson Prentice Hall, and yours is published by, does anyone know? Pearson Prentice Hall. 2 different vocabularies for the same word. Why in the world they chose to say manipulated and responding in the senior high version and then independent and dependent in the junior high version, I don't know. Well, I think when you think about it as manipulated and responding, it kind of makes more sense. Like the definition makes more sense. Manipulated is the thing you change, right? It's the thing you manipulate. And then responding is the thing that responds to the change. But most of the time you're going to hear independent and dependent. Okay, so we're kind of using the 2 interchangeably right now until we kind of settle on one, or we may not even settle on one because it may continue to come up in labs throughout the year where we'd be like, what is the other word for this? All right, so let's see. A hypothesis must be what? Anybody? Yeah, testable. Very good. All right. A testable hypothesis is a hypothesis that can be proved or disproved or supported or not supported as a result of testing, data collection, or experience. Only testable hypotheses can be used to create and perform an experiment using scientific method. If you can't test it, it's not a hypothesis, right? A hypothesis. Because you got to be able to test it.
It's really hard to say.
If you say it enough times, then it starts to get like, yeah, like that weird Spanish dialect. There's a Spanish dialect. Have you heard it? Not Spanish like South American, Spanish like Spain. There's one Spanish dialect that's all. That's how I felt by the end of it. All right, let's ring this time for who wants to volunteer to read.
Me.
Ring if you want to read. Delia. All right, go for it. What is scientific method? Let's read the first paragraph. Delia, go for it. Oh, no, I'm sorry. Requirements for a testable hypothesis. I'm wrong. Go ahead.
In order to be considered testable, 2 of these 3 criteria must be met. It must be possible to prove that the hypothesis is true. It must be possible to prove that the hypothesis is false. It must be possible to reproduce the results of the hypothesis.
Excellent. Okay, so here's where we get to the true, not true, supported, not supported business. All right. So
My brain.
what do we have to have for a testable hypothesis? It has to be proven to be either true, which is also what? What do we call that really? We call that supported, right? And sometimes you're going to hear like proven, right? But really, this is the one we like. And what's the other one? It has to be what?
False.
Right, so false, which, what would they say for that?
Disproven.
Disproven. And what would we call it? What's a better word?
Non-supportive.
Unsupported, yep. That's one way to put it. There's a couple different ways you can say it, but that's a good one. Unsupported. All right. And then what's the other thing it had to be, Delia? What did it say?
It must be possible to reproduce.
Reproducible. Okay.
Miss Tammy,
Yes.
can we close the blinds?
Yes, go for it. Especially if you're hot. Okay, it has to be reproducible.
Yeah.
All right. Why does it have to be reproducible? True.
Because if you only do it one time and it works perfectly, you're like, see, this one, it works 100%. Every time, you don't really know.
Right. You don't know if it's a fluke, right? Absolutely. Right. So there's something called, let me write this one for you.
You want me to get it for you?
Can you get it, Savannah? Do you need help?
Wait.
I can get it if you need help. Oh, there, she's got it.
I can't do it.
All right. Does anybody know? Okay, you know what this means, right?
Other way.
Yeah, I gotta kind of pull it towards that way. Do you want me to help you? Yeah, I'll get it.
I can't even do it. I just pulled it down.
Here.
I was just.
You guys pull it down.
Why is someone
over a little? Here it goes.
I thought it was gonna hit me.
It's stuck in the frame. Okay. There we go. All right, Rattler, you know what that is? That's easy. What's that? Okay, if that's equals, dingy dingy, what do you suppose this is?
Well, doesn't equal?
Not equal, okay? You're gonna see this in your life a lot of times, okay? This is not equal. All right? Not equal. All right. This is a big one. You might want to write this down somewhere in your notes, like on somewhere on the side of your paper. What's that word?
I don't know. Can't even pronounce it.
Can anybody do that one?
Cossetin?
How about I break it down?
Cavitation.
Cause. How about if we did it that way?
My brain's confused.
Causation. Okay, good. Causation. What do you suppose causation means?
Like causing something?
Yes,
Like
something is caused, right?
Yeah.
Something happened, all right? Does not equal, and here's the big one. Are there two L's in this word?
Write it
I
down.
think there are two L's in this word. I had to check it.
Correlation?
Correlation. I think there are two L's in correlation. I would have to check
Do you
it.
need to write that word down too?
Yes,
I
okay.
just finished writing down the first word.
That's fine. So causation does not equal correlation. I'm gonna double check if there are two L's in that word. Oh, here's my phone. I'm not good at spelling on the board. I can spell on paper, but for some reason when I start to write on the board, I cannot spell.
Somewhere.
Oh, there's one L. I knew I'd be wrong.
I'm
All right.
ready.
See, there you go. All right. So what is correlation? Does anybody know?
What? Is it like quarantine?
Okay, so
Coral Rose.
I don't even know what quarantine is.
okay, so correlation is a relationship between things. Okay? All right? So here's what it means. Just because there's a relationship between two things, it doesn't mean one caused the other. Okay? So I'm going to write that at the top, and you might want to find a spot on your paper somewhere to write it.
Wait, what?
So I'm going to write it. We're going to try not to write too many notes in this class, but sometimes we're going to. Just because there is a relationship. That thing keeps going, doesn't it? Whoops, sorry, ran out of room. It's
What the heck is happening?
It
Wait, what?
doesn't.
Oh my god.
Wait, are we supposed to write this?
Yeah,
Yes.
you can write this. You can take your time. Doesn't mean
I'm just going fast.
one cause. And remember, you can always go back and look at these videos. I upload every one of them, right? The other. All right. While you write, I'm going to tell you the best story I can to
I'm
explain
not
this.
done.
Take your time. Causation does not equal correlation, all right? My high school French teacher was this awesome lady who grew up in this tiny little town in Massachusetts. And it was a little village that was entirely French speaking. This little,
Bonjour.
yeah, bonjour.
That's the
This
only
little-
one I know.
This little pocket of French people that had transplanted themselves to this tiny little place in, like, I want to say it was like northwestern Massachusetts, okay? And everybody spoke French. All the storekeepers, the school, everything was French.
Get a translator.
Yep. So her mother was French, and her father was, you know, Heinz 57, run-of-the-mill American dude, right? And he spoke zero French, not a drop of it, and never cared to learn.
Really?
So
Not even bonjour?
here, not even bonjour. So here's the thing.
Bonjour.
Here's your example of causation and correlation. She woke up in the morning and spoke French with her siblings and her mother, went to school and spoke French with her siblings and her classmates and her teachers, came home and spoke French until the sun went down and her dad came home. And then they spoke English. She thought, until she was about 8 or 9 years old, that you spoke French when the sun is out and English when it's dark.
Wait, so
Because she didn't realize that they were changing languages because her dad didn't understand the French. She thought it had to do with the sunset. That is correlation. You speak one language when the sun is up and another when the sun is down. Okay, that's what you call correlation. There's a relationship.
Is relationship the end word? I can't
Yeah,
really
relationship. Sorry. Oops, push that back a little. Sorry.
Ugh.
So the relationship was whether the sun was out or not and the language you speak. But did the fact that the sun went down, was that the cause
Nope.
for them to start speaking English?
I don't have any more room on my page.
That's okay. Don't worry about it. Flip it, turn it over, write wherever you want. And I've got spare paper too. I can always bring some of that over if you want some. So that is causation and correlation. Here's another one. Say for 4 weeks in a row, every Monday it rains. Is it raining because it is Monday? No. So that means there may be a correlation. It may be raining on Monday, but that's not the cause, right?
It's
So-
because plants need water.
But it's important to understand that because we have to understand causation and correlation, because that way, this is what it means by a reproducible hypothesis. If you went to another town on Monday, would it be raining there every Monday and go, oh, this is definitely the cause of it? No, right. You can't reproduce that always. And I know it's like
I'm not
all
doing it.
excited about. It's just excited. I know. And do you think every town in America suddenly stops speaking French at sunset? No.
No.
So it's not reproducible, right? All right. So everybody about got that almost? Almost? All right, good. So I'm going to read the next paragraph for you, and I'll stop at the blank and you fill it in. So what is scientific method? Scientific method is a systematic method or a series of steps, including observation, forming a hypothesis, experimentation, data analysis, and conclusion used to collect information or solve problems, right? All right. One step in the scientific method is what?
Observation.
Observation, okay. That's what we're going to be doing today in our lab. It's mostly observation and hypothesis is today's lab. And it's a really fun lab. We did it last year and we're repeating it because every time you do it, it's different and you can learn something every time you do it.
I wasn't here last year.
Yeah, I know, but I'm saying like some of these other guys in your lab group, they've already done it, but it's cool because it'll be fun. All right, so observation consists of receiving knowledge to the outside world through our senses or recording information using scientific tools and instruments. Any data recorded during an experiment can be called an observation. So if you see something, is it an observation?
Yes.
How about if you touch it?
Yeah.
Yep. How about if you smell it?
Yeah.
How about if you taste it?
Yeah.
You gotta be careful what we taste in labs. Ugh.
Yeah, don't
And
say
how about if you hear it?
Hydrochloric acid. Yum.
Yep, very good. All right, so all those things. And then I talked about vestibular sense. Does anybody remember what that was?
You can feel where you are in space.
Yeah, it's your positioning of your body within space. It has to do with how you're moving. Like if you're in a car and you close your eyes, you can tell if you're turning left, right, up, going up a hill, down a hill, right? That's
I love
vestibular.
going down big
And
hills.
those of us that have whacked vestibular apparatus get motion sick all the time. That would be
I
me.
used to get car sick.
Yeah, you too.
I used to
It's
get car sick
awful.
so much.
They actually asked me that before they put me into surgery, because I guess people that are motion sick are even more prone to like being really sick after surgery. And they gave me like the best anti-nausea medication. They put a patch behind my ear, a prescription patch, for 3 days so that I didn't feel nauseous. It was beautiful. It was absolutely beautiful. All right, let's do this next paragraph. All right, another step is forming what? Another step is forming a hypothesis. All right, good deal. It's the initial building block of the scientific method. Many describe it as, you got it, an educated guess based on prior knowledge and observation. While this is true, the definition can be expanded, so we can expand that definition and get really specific with hypothesis. And we said sometimes they're proposed in a what format? If,
Just read
then,
it, but
right?
just
If, then, but not always if, then. A lot of the time they are if, then, right? All right, so once, why don't you do the next paragraph for me? Go for it. Go for it, Jack, just read.
All right. Once a hypothesis is formed, it must be tested. Scientists and other people test hypotheses by conducting experimentation. It's been a long.
Yep, experiments. Good
The
job.
purpose of an experiment is to determine whether observations of the real world agree or conflict with the predictions
Derived.
derived
Mhm.
from a hypothesis.
What's derived? Does anybody even know what that one means? Derived, that's a good word. Okay, so derived would mean like developed from. Like some words are, they'll say derivative of other words, and it's a word that's like, oh, I'm trying to think of a good example now. Like, now my brain is going blank on me and I can't think of any. But it would be something that comes from it. Like the initial thing is the root, and you pull out of it and grow out of it. So the purpose of an experiment is to determine whether observations of the real world agree with or conflict with predictions derived from a hypothesis. So you come up with your hypothesis, you conduct your experiment, and your whole point is to see whether or not the data you get agrees or disagrees with what you initially thought would happen, okay? And sometimes it's gonna agree and you'll be like, oh, yeah, obviously. And other times it's gonna be completely not what you thought. And those are actually the fun ones, I think. All right, who wants to read this next paragraph? Anybody? Let's see. What, Savannah? You go.
Where is it?
Okay, next, the data collected.
Next, the data collected from the observation and experiment must be data analysis. Generally speaking, scientific data analysis usually involves one or another of the following 3 tasks: generating tables, converting data into graphs or other visual displays, and/or using statistical
tests. Yep. So analyze. That could be their blank there. Okay, excellent. All right, that's good. So why would it be a good thing to use a table or a graph as opposed to just writing out your data? Does anybody know why? No? All right. You've heard a picture's worth 1,000 words, right?
Yes.
Okay. If those of you guys that did, when you did your homework last week and you did the cats, right? The cats in the shelter, and you did the graph with the cats in the shelter. If I said to you, there were, and I started reading all the different ones, you would have to read and try and keep up with it all in your head. All right. And then you'd have to go back and think about how they compared to each other. But if you put it in a graph, you can look at it and you can just see it, right? You don't have to read like word for word for word. And graphs are really good to show not just how data compares, like were there more gray cats than hairless cats. You don't even have to think about it, you just see it, right? Yeah, that was last week's homework. Or to show trends, like this is increasing. The number of, if you look at graphs for like the number of homeschoolers, let's see if I can find one to show you.
I'm a homeschooler. That makes it so excited.
Let's see, population of homeschoolers, and let's say by year. So do you think there are more or less homeschoolers by year? You think there are more?
What?
Okay, so now I could read this to you where it says the investigators mailed and printed questionnaires to almost 206,000 households, blah, 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 blah. Or we can look at it and go, oh, oh, look, here's a graph, and this graph, well, this was on, okay, this one's specifically on race and ethnicity of homeschoolers. And it compares different race and ethnicities of homeschoolers.
I just want to buzz
Mhm.
like they're so
And
bad.
then let's see. Oh, let's see. Where's, oh, here. This is the one we want. All right, now, I'm going to read this to you, and then I'm going to show it to you, and you tell me which way is easier to understand. In 1999, there were 850,000 homeschoolers. In 2003, there were 1,096,000 homeschoolers. In 2007, there were 1,508,000 homeschoolers. And in 2011, there were 1,770,000 homeschoolers. I can say that or I can show you this. Which one's easier?
Showing.
Can you see that it is increasing?
Yes.
Yeah. Can you see that it's like a gradual, right? Yeah, okay. So that's a great thing to consider. Graphs. Always graph when you can. All right. Let's see. We are on, lastly, what? Next paragraph. Lastly, a conclusion must be drawn about the hypothesis. Scientists draw conclusions.
Everybody.
Scientists draw conclusions by examining the data from the experiment. There are basically two possible outcomes, right? Two. That's it. Either the experiment supported the hypothesis, and it can be regarded as true or proven, however you want to say it, but typically we're going to say supported. Or it disproved it, it's unsupported, and it's false, right? It's one or the other, all right? So what do we do if it is proved or supported? What do we do? What's the next thing say? What if I, do you have it? You don't? Oh, I thought it was your hand.
It's 6 months a year.
No, have you?
Oh.
It says, what if a hypothesis is proved or supported? What do we do? What's the next sentence say? Who's got it? Eleanor, you got it?
When a hypothesis is proved, supported,
Yeah.
a scientist will make sure she can repeat her process and replicate her results.
Excellent. Repeat her process and
Next
replicate
time I'm gonna buzz the buzzer.
her results. Excellent. All right.
I can't look.
You can't replicate it. It's not a good, it wasn't a good hypothesis to begin with, and it's probably not a well-conducted experiment. All right. And then how about, what's the next one say? Anybody want to do the next sentence?
Sure.
Go for it, Jack.
What if a hypothesis is not proved true or it's supported
Mm-hmm. Or rejected.
or
Uh-huh.
rejected?
Uh-huh.
A scientist will revise his hypothesis and often repeat the experiment.
So what are we doing in both cases? Whether it's supported or rejected, what are we doing in both cases?
Wait, what?
What-
Testing.
Yeah, but look at what it says. What if it's proved or supported, and what if it's not supported?
Oh,
What are we doing in both cases? What are we doing?
repeat.
We're repeating it. Right. You have to repeat it. So in lab, you guys aren't going to have the opportunity to repeat your own experiment again and again and again. But how many lab groups do we have? We have 4 lab groups.
I thought there were 2.
No, there's 4.
2.
So essentially, that is our repeat. Okay? That's what's going to happen is the 4 groups are going to repeat. Everybody's doing the same thing, and that is your repetition. So it would be the same as you doing it again and again, except we're throwing in one more variable, and that would be that it's another team. We have to kind of assume, you don't want to assume in science, but we have to kind of assume that everybody's going to do it the same way. And truthfully, they won't. And that's a variable we always have to consider. Somebody may not measure as well as somebody else. Somebody else's scale might not work as somebody else's scale might not work as well, right? What you got, Eleanor?
My dad's favorite puppet is Beaker.
I love Beaker.
My
He's
dad
the
loves
best.
Beaker too.
Okay, do you know that,
I love Kermit.
here comes my opinion for the day. That awful Camila Cabello song,
What?
well, which one is it? I want Beaker. I want somebody to do like a little video meme of Beaker singing that song.
Deal.
Yeah.
Deal.
Because it sounds, every time I hear that song, I envision him singing it because that's exactly how she sounds.
Deal. Check out Eleanor's. Deal. I'll do that on my YouTube channel.
Do it. You got a YouTube channel? Awesome.
Eleanor's Amazing World.
Oh, I got to look this up. Okay, awesome.
too.
Yeah, you do too. All right, so remember that.
Wait.
All right, so hang on. Let's wrap this up. We're almost done. So remember that a scientific method is less of a straight line, and it's more of a path with lots of opportunities for U-turns. Because you want to try and follow a method, but there's going to be times when things are proven, disproven, supported, unsupported. You got to turn around and go back and do it again. All right, so let's talk real quick about what variables are. All right, variables are the various aspects of an experiment that can be changed or controlled by the experimenter or changed by the experiment. There are 3 types of variables, right? 3. All right. All right, I'm going to read it, and then we're going to write them up here. We have independent or manipulated, and they're the ones that can be manipulated by the experimenter. Then you've got, and they can cause a change in another variable. You got dependent and responding, same thing. And they can change if other factors change, and they can change in response to the manipulated variable. And then you have controls. All right, it's important to conduct a controlled, controlled experiment. That's your blank there, controlled. Make sure you got that. You got that, Drew? Your blank says controlled.
Wait,
A
what?
controlled experiment.
Yeah.
All right. Because a controlled experiment is one in which only one variable is deliberately changed. Okay. Did I tell you guys, did I give you guys that headache example last week? I can't remember if I gave that to you or the other group.
I
gave it to you. All right. So here's your,
What does heal a headache? I get headaches a lot.
yeah, depends on what's causing it, I imagine.
Brothers.
Brothers? Oh, well, ibuprofen, yeah, Tylenol, whatever. All right, so you've got an independent variable, okay? You can write if you want or not, depends on what you want. And then you have a dependent, and then you have a control. All right, let's say in our headache experiment, so headache.
This thing is fun.
Headache. Whoops. Headache versus what? What are we going to try and treat it with?
Tylenol.
Headache versus Tylenol.
Ibuprofen.
Let's do Tylenol.
No, that's for stomach.
That's for stomach aches. Okay. All right. Excellent.
Wait, what's for stomach ache?
Tums, he said.
All
All right. Here we go.
Thomas the train.
All right. Here we go.
Thomas the train.
What is our independent variable in our experiment that we're going to conduct with our headache versus Tylenol? This is, can Tylenol fix the headache?
Yeah. I don't know.
What's the thing we're adding that we're trying, what are we trying to add
Get
to
rid
this
of the
situation?
headache.
Tylenol.
Tylenol.
This is Tylenol. Okay, what's the dependent variable?
Headache.
The headache. Very good. You guys are so good. I love it.
My brain's confused.
All right, now here's the tricky part. What are all the controls? This is where science gets hard. This is where science gets really, really, really hard. So what are all the controls? Think about all the things that can be controls.
I'm gonna plug in my brain.
Let's say let's say on Monday you have a headache and you don't do anything. And then on Tuesday you have a headache and you treat it with Tylenol. All right? And these are your experiments, okay? So what are all the things that are going to be a control? So the first one's obvious. That's nothing, right? You take nothing, no meds,
Is
right?
it close to doing math? Oh, I have
Yeah.
meds.
All right, now, here we go. What other things do we need to control for?
The amount of noise.
Yeah, sure. That can give you a headache. What else?
Wait, what?
Avoid
A
like
screen.
moving.
A screen.
Sure, how much you move. Screen, what else?
People talking at the same time really loud.
Yeah, that would be noise. Okay, what else?
Being dehydrated.
Dehydrated, that's a big one.
That gives you a headache?
Oh, yeah.
That never gives me a headache.
A ripping headache. What
Having
else?
no food in your body.
That's right. We'll say, we'll call it this. Blood glucose. That's your
usually-
sugar level in
That's
your blood.
usually how Ethan gets it.
Uh-huh.
Because he doesn't eat.
All kinds of stuff. What about light?
Too much eating.
What about, yeah, too much, that's all blood glucose. What about, okay, so we did light. What about sleep?
Oh.
What about types of food that you ate? Maybe you ate a food that doesn't like you. Or maybe you had maybe your blood sugar level's the same, but one day you used aspartame and aspartame gave you a headache. Sometimes it does. Gives people a headache. Who knows? It depends. So, okay, if any one of these,
Doing too much.
So, listen, if Monday you take no meds and you figure this is your control, this is what you're doing. You're taking no meds, all right? And you see how long it takes for your headache to go away.
I know.
And if Tuesday you add Tylenol and you see how long it takes for your headache to go away. If any one of these is different between Monday and Tuesday, it's not controlled. So it's really, really hard to control an experiment. Yes, ma'am.
One is stress when you're like kind of really
Yeah.
stressed.
There you go. There's another one.
You
Yeah,
can also get a heart attack.
that's true. You can. What you got, Delia?
You could get a headache by not drinking enough water.
Yeah, that'll give you, that's this dehydrated one. That is a terrible headache. Not only is it a headache, but
it's
you
really
feel
bad.
nauseous and awful.
Oh, I hate when
Too
I
many
don't
Red
watch
Bulls.
it.
Too many Red Bulls. Caffeine, that's another one.
Oh, I used to drink
So here's what you
caffeine.
need to consider. When you read, also, I want you to really consider this. You guys are gonna get too much work. All right, so listen as we wrap up here, and then we're gonna real quick look at our homework answers, and you're gonna hand them to me real fast, and I'm gonna hang on to them. But wait a minute.
The
So-
homework that we had.
Yep, I'll probably be able to give it back to you today, which should be super. All right. So here's what I want you to remember. Remember this when you're conducting experiments, but also remember this when you're reading articles about stuff. A couple years ago, there were these girls who what did they do? They tried to grow something like grass seed next to a cell phone charger or something. And yeah, something like that. And it was all over the news. People were like, oh no, it didn't grow. But they didn't control for temperature, sunlight, none of these things. No, when you read it, they kept one in one room and one in another room. It's totally different. So you have to remember this. Control is huge, 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 huge. And it's really difficult. If your experiment is complex, the more complex it is, the harder this experiment is. An experiment that I conducted in college, I used mice, and I tried to make sure that my mice were pre-adolescent when I got them.
Did you give them injections?
I did not, but I had to make sure that they were pre-adolescent when I got them, and
that mean?
meaning they hadn't hit mouse puberty yet. They were still baby mice, not adult, sexually mature mice, right?
What's so
And
bad about adult mice?
It just, for my experiment, they needed to be on the younger side. And some of my mice clearly were not, because one of them delivered 12 pinkies a couple weeks into my experiment. I watched her getting whiter and whiter. Pinkies are the baby mice, the little tiny pink baby mice. And they were not supposed, they were supposed to be pre-adolescent, right? So they shouldn't be able to reproduce, and they shouldn't have been around. They also should have been separated by sex. So no female mice should have been mixed with male mice ever. Should never have happened when I drew them out of the animal supply room. And I had I had a female mouse that had 12 babies. So I'm like, this clearly messes up my whole experiment, because I don't know.
Experiment.
It was a very involved senior research experiment. That
And
would
how do you then give them injections?
No, I didn't give them injections. I fed them a medication, but it came to them in peanut butter.
Otherwise,
All right, so somebody tell me what your answer was for number one. I'm just curious to see if you guys, on your homework, where it says weekly questions. And then after we go over them real quick, you can hand them in. So
I don't know what
if you don't have it today, don't panic. This is why we're doing it, so that you understand.
Never mind. I got it.
Okay, good. So what's the page number you have? 7. Okay, so this is 7, lesson 3. We've got 2 minutes.
Oh, I have lesson
All right.
2.
Okay, so listen. Oh, it's 7, lesson 2. I'm sorry. Lesson 2. Yeah, sorry. 7, lesson 2. All right, so this is what you're going to hand in every week. You're going to hand in your lab. Listening? You're going to hand in your lab, and you're going to hand in this. Okay, so some of you still aren't completely clear on what we're doing, so I want to make sure you understand that this is what we're doing. All right? So does everybody have it? Do you have it, Savannah, the right page in front of you? Listen to, what, is that it? It'll say weekly questions on top. Yeah. No, that's 3. That's the middle of lesson 3.
Yeah. Lesson 2.
That's lesson
number
2.
7.
So it looks like, can you
Looks
hold
like
this
this.
for a second?
Looks like
So it's gonna look like this. It's okay. I don't expect everybody to understand that it, the first week or 2. So that's okay. This is what you're gonna turn in every week.
Just this one?
That's one. Okay.
I had to keep going over and
So
over
we're gonna-
the video to get all the answers.
All right. So look, we're gonna go over this real quick together. Hang on one second, Delia. We're gonna go over it real quick together. I want you to look at your answers if you have them. If you don't have answers, go ahead and write them in.
Wait.
All right. And then this is what I'm gonna collect and grade for homework. I don't grade homework on accuracy. I grade homework on growing towards understanding the concept. I don't expect it to always be correct. As long as you give an effort to give a correct answer, you'll get credit. If you give a goofy answer, you won't. Julie, do you have a question?
Yeah, that's the right thing.
That's the right one. Excellent.
Oh, I can't find her.
All right.
Should I take
We'll look
it
for it in a minute.
out?
Yeah, because you're going to hand it in. I'll help you in a minute. Savannah, let's see. All right, so who has an answer for what is a hypothesis? Go ahead, Drew. What do you have?
Dang it.
Hypothesis is an educated guess.
Okay, that's good. An educated guess would be a good answer. I can help you with that. Oh, wait. This is it. No, this isn't it. Weekly assignment, lesson 2. Just got this is out of order, so that might be it. No, that's next week. It's going to look like this, though. All right, and it has Rico on the back. Now, for those of you, except you 2 guys who for some reason got single-sided paper, It's always going to have Rico on the back. All right. So it's
It says it's Rockstar again.
yes, because not everybody knew they could do it the first time. So we're going to give Rockstar one more chance, and then I'm going to make sure the next one is correct.
Oh,
All right.
So people who already did Rockstar, can they do Rockstar again?
All right. So I'm going to read. Y'all listen. A hypothesis is a proposed explanation for an observation, a prediction or an explanation that is tested by an experiment. It is a tentative answer to a scientific question. In science, a hypothesis is part of scientific method. You can put any and or all of that as part of your answer, okay? Number 2 is a hypothesis must either be repeatable and true or supported, or unrepeatable and false or unsupported. Or
Wait,
repeatable and
where
false,
are
sorry,
we?
repeatable and false. So we're on number 2,
Okay.
okay? Number 3, what is scientific method? So I copied it directly from above, but so as long as your answer is similar. Scientific method is a systematic method, a series of steps, including observation, forming a hypothesis, experimentation, data analysis, and conclusion used to collect information or solve problems. What are the 3 types of variables? Independent manipulated variables, this is exactly from above, can be manipulated by the experimenter and can cause a change in other variable. Dependent responding variables can change if other factors change and can change in response to a manipulated variable. Controlled variables are a standard for comparison. And number 5, what do you do if a hypothesis is rejected? A scientist will revise his hypothesis and repeat the experiment. So you guys have about 2-3 minutes while everybody gets down here for lab. If you want to kind of repeat it a little, you can, or fill it in if you can. And I'm going to put a little card up there. I don't have one yet. And that's where you're going to put your finished homework today.
I'm putting my paper bags on here.
That's fine. You can bring it next week. This week you can bring it next week, okay? Because if you need to catch up, that's all right. So this week you can bring it next week. What you don't ever want to turn into me are the notes that we went over today with all the blanks in them, because that's your study guide for your test. Okay?
Wait, what?
Keep those notes in there, right? Your homework you can turn in. You're doing it right. All right, I'm gonna.
Do I keep with the questions out?
Yeah, that's fine.
Okay.
All right, I'm gonna end this meeting. I hope it recorded. Oh, it did stop recording. Okay.